people were debating, is light a wave or is it made of particles?
So what causes that?
Well, if light were behaving as particles, you would expect them to go through each slit and just produce a bright spot underneath. So we would see two bright spots on the bottom of the box. But if light's behaving as waves, then the wave from one slit can interact with the waves from the other slit. I've got a demonstration here on a little pond where we can see this with water waves. I have two sources of ripples, which are basically like the two slits. When I create ripples with a single source, they travel out with circular wavefronts. Nothing particularly surprising there. But if I add a second source of ripples, then we start getting an interesting pattern. This pattern is created by the ripples from the two sources interacting with each other. Where they meet up peaks with peaks and troughs with troughs, the amplitude of the wave is increased. That's what we call constructive interference. But if the peak from one wave meets up with the trough from the other, then we get destructive interference and there's basically no wave there. And this is exactly what was happening with the light. When the light from one slit met up peaks with peaks and troughs with troughs, they constructively interfered and produced a bright spot. But if the trough from the wave from one slit met up with the peak of the wave from the other slit, they would destructively interfere and you wouldn't see any light there. It's light canceling itself out.
It's basically the same as like having two drops of water fall in a swimming pool.
That's right.
Get exactly the same
And then
pattern.
they go and overlap. As this ripple overlaps with those ripples, down the bottom, you get a series of, you get like a bright spot, and then a dark spot, and then a bright spot, then a dark spot, then a bright spot. Now there's a slight complication, which is that sunlight is composed of many different colors, and they have different wavelengths. So obviously they're going to meet up at slightly different points. And that's what caused the rainbowing effects as we go further from the central maximum. You saw the ones to the right were slightly colored.
Yeah,
that's
it's
because
burgundy.
the reds are going to meet up at different places than the blues.
And that's all that makes the colour differences, is different wavelengths.
Exactly.
That's amazing.